Hi guys, this is 2.6, the graph of y equals k over x and y equals k over x squared. There's your journal choice. I think you'll enjoy it. Objective and what's the point? This is basically the same point as yesterday because not all graphs are lines, so we're looking at yet another type of relationship that you'll encounter in the real world. It's the inverse variation and inverse square variation. And we're going to identify the properties of those variation functions and graph some of them and look at their graphs and then write the equation. So we're going back and forth today. Okay, words to know. Hyperbola. I'm a little worried about this section, to be honest, because we definitely need to work the activity in class, and I'm recording this before we work the activity. So you're going to have some questions on these notes if you hadn't done the activity. So I don't know how this will work out, so we might have to reteach this lesson in class. You guys really need to talk to me if you have lots of confusion here. Okay, a hyperbola. This is the graph of every function that has this form, y equals k over x, if k is not 0, okay? Here is basically what a parabola looks like. Okay, it kind of looks like two pieces. Whoop, there's one. And whoop, there's the other, okay? There's two separate parts of hyperbola, and each of these is called a branch. So this is a branch, and this is a branch. Okay, there are asymptotes in parabolas, and now I wish I wouldn't have circled those. Okay, if you notice, if I'm going up here, I'm going to get really stinking close to the y-axis, but I will never ever touch it. So I'm going to keep approaching it closer and closer and closer, and we will see this better when we do the graphing calculator activity, but I'll never touch it. The same thing on my way going down here. I'll get really, really close to that line, but I will never touch it. So they're actually not part of the graph. They're a boundary line, and you have to graph them. You have to graph them even though they're not part of the graph, because you need to say, look, these lines are going to get really close to the x and y axis, but they're never going to touch them. Do you see how this will continue? It'll just get really stinking close, never touch. Same thing going this way. Really, really close, never touch it. I'm going to tell you right now, some of you will miss points on the next test because you will not graph your asymptotes. So please, 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 please graph your asymptotes, because otherwise it looks like, especially how sloppy I drew this, it looks like, oh, that's for sure going to cross that. It's going to keep going. That is super duper bad because, remember what we talked about functions. If this was going to keep going, oh, that was really bad, pretend it was good. It's not a function anymore. Do you see this? It fails the vertical line test. So you need to really make sure that you draw the asymptote in so Mrs. Bruno knows, oh, this is just a hyperbola. It's getting really close to the x and y axis, but it will never touch it. That makes it still a function because it will still pass the vertical line test in every point. Okay? Here's what we're going to do. We're going to do an activity, and we're going to be graphing y equals k over x, and we're going to find out these things. You're going to want to include these in your notes, okay? The domain. And I'm going to readdress this because some people have a hard time with this. The domain is what x can be. If I go left to right, will this graph go on forever and ever? The answer is no. Some of you might say, oh yeah, it sure does. The answer is no. Okay. Will I go to the left forever? Yes, I will. This will continue to go forever and ever. Will I go to the right forever? I wish that wasn't in my way. Yes, it will. It will go this way forever and ever and ever. The problem is, if I was to trace it, I would pick up my pencil. I would pick up my pencil right here. Okay? X cannot equal 0. There is not a point on this graph where x equals 0. So this is a domain, the set of all x, such that x cannot equal 0. The same is true with y. And this should also make sense, guys, by looking at the equation. I wanted to mention that. You can't divide by 0. Like the math police come in and arrest you. It's really tragic, actually. Okay? The same thing is true with the range. I'm going to redraw my picture since it's so marked up now and sloppy. Okay, let's do a negative k value this time. Let's say it looked like this. That is so bad. Don't judge me. Okay. There's my asymptotes. There's my asymptotes. Same thing. I'm going to go up forever. I will go down forever. But I will never hit this point here at y equals 0. I pick up my pencil. Okay? And that should make sense because since y is 0 and k can't be 0, this would never happen. Okay, when k is positive, greater than 0, the branches are going to look like this. Your parabola will look like this with your branches in 1 and 3. When k is negative, your branches will be in 2 and 4. Okay, remember when you do quadrants, you do Roman numerals. There are two asymptotes always, and when they're in this form, y equals k over x, they're going to be at the x and y axis. It gets really close, but never touches those lines. Okay? So that's domain and range. Those are the big ones. Domain and range kids have a hard time with on hyperbolas. Here's a picture. This might be a nice thing to have in your notes. Again, it just says k is positive, domain is this, range is this. K is negative, it's in 2 and 4. Domain is this, domain is that. Just a nice generic picture to have in your notes. All right, more words to know. Discrete set is when the domain skips numbers or when the domain is spaced out. Okay, so usually it looks like dots. And the reason you have situations like this is there's a great example on page 108 in your notes. They are graphing, let me see if I can find it here, the number of workers and the time to complete a job. You can't have half workers. It's awkward and people don't like to think about half the people. So when you graph this, the relationship ended up looking like this because there's not going to be half people, and that's like if all these were really spaced 1, 2, 3, 4. So they're each at the ones. You don't connect the dots if you have a discrete set. Now I kind of just lied to you. I connect the dots all the time when I am doing discrete sets. And then afterwards when I'm reporting my answer, I reflect and say, okay, I can't have a half a person. Don't do this. I do usually, I won't lie, connect the dots out of simplicity for when I am graphing and figuring. Okay? But if it was possible for me to neatly graph while putting the dots, I would do that. Okay? But you need to be reflective. Is this a discrete set or not? Can I have a half a person? Just know the context of what you're working the problem. Okay, now the next thing we're talking about is not just the inverse, the hyperbola. We're going to talk about an inverse square curve. It's different than a hyperbola, but it's very much related. This is going to be the graph of y equals kx squared. Okay, here's example 2. Graph y equals 36 over x squared in this window, negative 6 to 6. So everyone get your graphing calculators out and go ahead and do that. Why don't you sketch the graph and see what it looks like. And we're going to describe the symmetry. I'm going to get my calculator out here. Okay, y equals 36 divided by x squared. I'm using Inspire just because it works nicely on my computer screen. I can show you guys on the 84s tomorrow in class. This example. We'll be working on the other one anyway. So I'll go ahead and graph it. Okay, but that's not the window they asked for. So now I'm going to hit Menu. Window will be 4, and then Window Settings. They asked me to go from negative 6 to 6 for x. Oops. Menu. Shouldn't have hit Enter. I should have hit Tab. Negative 6 to 6. X scale will keep the same. Y min, let's go from negative 10 to 10. Okay, this is an inverse square curve. Okay, if I graph y equals negative 36 x squared, let's find my graph here. Negative 36 over x squared in the same window. We're in green now. Okay, an inverse square curve looks like a volcano. My students always call it the volcano graph. It is the inverse square graph, and the symmetry is I don't have my annotate over. It is symmetric over the y-axis. You could fold those pieces of the volcano and it would go over here. I wish I would have had the annotate over. Okay, so y equals 36 over x squared kind of looked like this volcano. That's a really bad picture. We'll pretend it's good. You guys are good at pretending at this point. And y equals negative 36 over x squared looks like this. Okay, they still have branches. So it is like the hyperbola in that way, but the symmetry lines are different. There's a symmetry line here, and we didn't talk about the symmetry line in the other one, and I kind of want to go back and do that now. There it is. The symmetry lines here are y equals negative x or y equals x. Okay, and on this one it was just the y-axis. Okay, here are your conclusions after doing activity 2, talking about the inverse square curves. There's still 2 branches, but it's not a hyperbola. It is an inverse square curve. The domain is very similar. Again, x cannot equal 0. The range is different here. Go back. Oh, go forward, I mean. I can go up forever, but I can't go down forever. It stops right here at this asymptote, which they did not graph, which makes me very angry. Goes up forever, but it will not go down forever. So that range is wrong. It's not y does not equal 0. It is y has to be greater than 0. This range is absolutely wrong. Okay? And this one can't go up forever, but it can go down forever. So we're right here. Okay, the same horizontal and vertical asymptotes. They do still have those asymptotes. Please graph them, or else you will whine about it later when you miss points on your test or quiz. Okay, so I would jot this down for your notes. I think I made the correction. This is positive k. It's kind of a happier graph than the negative k, which is frowning. Not really frowning, I guess, if you have a weird mouth. Okay, now you can work on your homework, enjoy it, or we can talk about it more in class tomorrow. See ya.